Hello, we're back with a new section, Deep Learning with Convolutional Neural Networks. In this section, we will talk about the architecture of CNNs and the type of layers used inside. We're going to see how to use a package called TensorFlow. We will then build a perceptron-based linear regressor. We're going to learn how to build an image classifier using a single-layer neural network and CNN. Now we move on to the first video of this section that deals with what convolutional networks are. In this video we will start with deep learning and how CNNs are used in deep learning. We will then see how CNNs are built and their different layers. So what is a deep neural network? If we build a neural network with many layers, it's called a deep neural network. The branch of artificial intelligence dealing with these deep neural networks is referred to as deep learning. One of the main disadvantages of ordinary neural networks is that they ignore the structure of input data. All data is converted to a single-dimensional array before feeding it into the network. This works well for regular data, but things get difficult when we deal with images. Let's consider grayscale images. These images are 2D structures, and we know that the spatial arrangement of pixels has a lot of hidden information. If we ignore this information, we will be losing a lot of underlying patterns. This is where convolutional neural networks, CNNs, come into the picture. CNNs take the 2D structure of the images into account when they process them. CNNs are also made up of neurons consisting of weights and biases. These neurons accept input data, process it, and then output something. The goal of the network is to go from the raw data image in the input data to the correct class in the output layer. The difference between ordinary neural networks and CNNs is in the type of layers we use and how we treat the input data. CNNs assume that the inputs are images, which allows them to extract properties specific to images. This makes CNNs way more efficient in dealing with images. Let's see how CNNs are built. CNNs explicitly consider the structure of images when processing the data. The neurons in CNNs are arranged in 3 dimensions: width, height, and depth. Each neuron in the current layer is connected to a small patch of the output from the previous layer. It's like overlaying an n by n filter on the input image. Since a single filter cannot capture all the nuances of an image, we do this m number of times to make sure we capture all the details. These m filters act as feature extractors. Now that we know about the architecture of a CNN, let's see what type of layers are used to construct it. First is the input layer. This layer takes the raw image data as it is. Second is the convolutional layer. This layer computes the convolutions between the neurons and the various patches in the input. If you need a quick refresher on image convolutions, you can check out this link. Third is rectified linear unit layer. This layer applies an activation function to the output of the previous layer. This function is usually something like max of 0 and x. This layer is needed to add non-linearity to the network so that it can generalize well to any type of function. Fourth is pooling layer. This layer samples the output of the previous layer, resulting in a structure with smaller dimensions. Pooling helps us keep only the prominent parts as we progress in the network. Max pooling is frequently used in the pooling layer, where we pick the maximum value in a given k by k window. Lastly, we have the fully connected layer. This layer computes the output sources in the last layer. The resulting output is of the size 1 by 1 by L, where L is the number of classes in the training dataset. As we go from the input layer to the output layer in the network, the input image gets transformed from pixel values to the final class scores. Many different architectures for CNNs have been proposed, and it's an active area of research. The accuracy and robustness of a model depends on many factors: the type of layers, depth of the network, the arrangement of various types of layers within the network, the functions chosen for each layer, training data, and so on. That's all for this video. We learnt the basics of CNN here.